Okay, we're going to take a look now at sketching graphs. We're going to use differentiation, but we're going to use a few other things as well. Let's have a look at this example here. Sketch the graph of y equals x minus 1 plus 4 over x plus 1. Okay, so you've done a lot of sketching of graphs by now. You know, you're pretty good at linears, I imagine, and quadratics. And earlier in the year, we looked at this section here on graphs, and we looked at all sorts of things. Rectangular hyperbole, look at these things. Square root graphs, remember this stuff? Cubics and quartics, circles, all that. Well, we're going to look now at a different type of graph again, and it's brought about by, we've got a fraction here with x underneath. That brings in some changes, although we are used to that with hyperbole. But this x minus 1 just changes things up a little bit as well. So let's get to work on this. Let's get a number plane together and start to consider how we're going to construct the graph of y equals x minus 1 plus 4 over x plus 1. There's my x, there's my y, you get the idea. Okay, so firstly, asymptotes. Let's consider asymptotes. So we know, don't we, from here that x can't be equal to minus 1. So this is from previous work, and it creates this break in the graph, which means that we've got a discontinuous graph and a couple of branches, and that can be a hyperbola or a truncus or whatever. But in this case, we can't have x can't be equal to minus 1. So let's make a note of that. X equals minus 1 is a vertical asymptote. Okay, so let's get that in place at minus 1. Right, down he goes there. Good, minus 1. X can't be equal to minus 1. All right. Now I want us to think about this x minus 1 and what the effect of that is. And this is how we're going to do it. We're going to have a look at the value of y, the value of this function as x approaches infinity. So let's think, because that's how, remember, if you think about how we came up with our horizontal asymptotes, we looked at values of the function as x grew towards infinity in both directions, positive and negative. So as x approaches infinity, so what's going to happen here as x approaches infinity is that this fraction here will go to 0. Imagine 4 over a bazillion and 1. That is going closer and closer to 0. So if that's going to 0, then what's y going to? Y is going to a bazillion and 1 minus 1. So it'll go to x minus 1. So this holds, this goes to 0, and so an asymptote is actually going to be this here, x minus 1. So x minus 1 is an asymptote. So that's what's called an oblique asymptote. It's going to go through minus 1 here on the y-axis and have a gradient of 1, so it's going to be something like this. It's a pretty funky looking graph. So what we've got is x approaches infinity, y approaches x minus 1. And we're the same as x approaches minus infinity. This will be 4, this will be very small negative. Y is approaching x minus 1, but that'll be from below. And this will be from above, I believe, as y approaches x minus 1. This is positive infinity. This will be slightly greater than 0. So from above, we're approaching x minus 1, and from below. So from above, if you think about as x approaches minus infinity, then this is a small negative value, and so we've got just less than this. So this is from below. Okay, so that's some information. So now we're going to have two branches, but this is what's called, I mentioned it, but I need to write it down. This is what's called an oblique asymptote. And I believe that'll be your first look at an oblique asymptote, and this is our more familiar vertical asymptote. Okay, so what else can we find out? What about finding out the intercepts? So axes axial intercepts. So where does it hit the x and y axes? Well, if we make the y-intercept is at x equals 0, and then when x equals 0, y is equal to 0 minus 1 plus 4 over 1, so minus 1 plus 4, which is equal to 3. So we're going through, what am I going to call it? We're going through 3 on the y-axis, so we're going to go through here somewhere. That is when x is equal to 0. When y is equal to 0, can we solve that? When y equals 0, so if we have a look at our x-intercept, will be when y equals 0, so that's x minus 1 plus, so therefore when x minus 1 plus 4 over x plus 1, when that's equal to 0. Okay, I just paused there to do this calculation. So we're looking for the x-intercept, made y equal to 0, try to solve this through. As you can see, what happens here if I blow this up is trying to solve this equation here, multiply this x plus 1 across here, we end up with x squared equals minus 3. So there is no x-intercept because there's no solution to that. So we're not going to go through the x-axis, which is fine. I think that all makes sense. Okay, so we're now going to look for, we're going to use our calculus knowledge to find out where the turning points are, if there are any turning points. So how do we find turning points? That will be at dy dx equals 0. So we now need to go up and differentiate y equals x minus 1. So let's get to work on that. So we've got y equals x minus 1 plus 4 over x plus 1. Need to get that in differentiable form, so we get it as x minus 1 plus 4. This will be x plus 1 to the minus 1. Now it's in differentiable form, we can say dy dx is equal to 1. That goes. This minus 1 comes down here, so it's minus 4. Oops. Sorry about that, not sure what happened there. I could bring this minus 1 down, minus 4. We've got x plus 1 in here, minus 2. So we end up with 1 minus, and it'll be easier if we've got 4 over x plus 1 all squared. So that's my dy dx. Now where is that equal to 0? So it's 4 over x plus 1 squared equals to 1. If we bring that across there, and therefore x plus 1 all squared is equal to 4, and therefore x plus 1 is equal to plus or minus 2. Continuing, x is equal to subtract 1, we get x is equal to 1, or that's for positive 2, 2 minus 1 is 1, negative 2 minus 1 is minus 3. So 1 or minus 3, and at those values y is equal to, put x equals 1 back in up here, you get 1 minus 1 is 0, plus 4 over x is 1, 4 over 2 is 2, so we get y equals to 2 there. Or when x is minus 3, we get minus 3 minus 1 is minus 4, and you put minus 3 plus 1 in there, so you get minus 2 there. Minus 4 minus 2 is minus 6. Just check that. Okay, so we've established now turning points at 1, 2, and minus 3, minus 6. So I've just written that out there. Now we just need to establish what they are, what the nature of these turning points are. So we'll do a 0, 1, 2 check on x equals 1 here, and we'll do a, on minus 3, minus 6, we'll go from minus 4, minus 3, minus 2. Do a check on that, and this will be f dash x. So we know that we've got 0 here and 0 here. So at 0 we're looking for the derivative, which I've written out as 1 minus 4 over x plus 1 on 2. So put 0 in there. 0 plus 1 is 1 squared, which is 1. 4 over 1 is 4, so 1 minus 4, so we've got a negative there. Put 2 in here. 2 plus 1 is 3 squared is 9. 1 minus 4 ninths, that's going to be positive. So it looks like at 1, 2, I've got a decreasing, 0, increasing. So I've got a minimum there,
and let's just check. Put minus 4 in there, add 1, you've got minus 3, square it, you've got 9, 4 ninths, 1, 1, that looks positive to me. And when you put minus 2 in here and add 1, you've got minus 1, you square it, you get 1, 4 over 1 is 4, 1 minus that's gone negative. So we're increasing, 0 decreasing, and got a max at minus 3, minus 6. So now let's get all that information. 1, 2, and minus 3, minus 6. 1, 2, 1, 2, and minus 3, minus 6. Now let's think about where that is. Minus 3, minus 6 is going to be underneath here, down there somewhere. Okay, there, that's my max. So what's going to happen is that's going to drift down there, and this is my min through my y-intercept at 3, and off we go in that direction. And so there's my two branches that are framed and hemmed in by my oblique asymptote and my vertical asymptote. My oblique asymptote is this here, x minus 1. So when we've got functions of this nature, we get a little oblique, we get a vertical with that, and we've got a little bit of work to do. We need to find out our intercepts as we've been accustomed to doing, but also now that we know calculus and differentiation, we find these turning points here, which I should just note in as what do we say? 1, 2 here for a little minimum, 1, 2, and a little max at minus 3, minus 6 right there. Okay, time to get some practice in class on this stuff, and that'll be 22E on page 635. So exercise 22E, page 635, questions to come. Okay, questions 1 and 4. I believe we'll do the tricks, page 635, 22E. Okay, I'll see you soon.